Okay. All right, everybody look in your book. And these are, even though they're called leftovers, I didn't say they weren't important. I just said they didn't quite fit in the history part. They didn't fit in the isotope and ion part. But they're kind of like leftovers. So this is the rest of the chapter here. Now, we know about elements, right? And most of the elements exist as single atoms next to single atoms next to single atoms. Like if I had a balloon full of argon gas, it would be a little argon atom, another one like that. And that's what most elements are. But God, he wanted more variety. And he made some elements diatomic. What does that mean? Two of the same kind bonded together, right? So he actually made a compound out of it, even though they call it a diatomic element. Now, what are the diatomic elements then that we know of on this planet? I know you can't remember everything. Sorry, if you could close that door for me. And you can close that door too and unplug that wire so that, yeah, sorry. What are the ones, there's a memory device. What was it? Cardi, go ahead. So what elements end in GEN? Oxygen, nitrogen, and hydrogen. So if I had a balloon full of hydrogen, it wouldn't be H, 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 H. What would it be? Lauren, help me out. What would it be? What would be in a balloon full of hydrogen gas? Would it be H, 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 H atoms? And they're not because they're diatomic. So what would it be? Two H's together. H2, H2, H2. See that? What are the other ones besides the ones that end in gen? What are they? You said a good word. What is it? The halogens. That's going to be on there too. Does everybody know where the halogens are? Do you know where the noble gases are? Alkali metals? Alkaline earth metals? Transition metals? Great job. All the halogens are diatomic. There you go. You okay on that? Okay, I got that. That'll come in handy later on in the year, all right? Now, this word here, it sounds so much like isotope. But we know that isotopes have to do with the nucleus of an atom, don't they? And that's a particular atom is an isotope, right? And this isotope has a mass of 12, this one has a mass of 13. That's isotopes. What are allotropes? God also did this. He said, I want to make elements in having different forms also. And like, for example, what is the stuff that you breathe? What form of oxygen do you breathe? O2. This is the stuff you should not breathe. It's called O3, also known as ozone. Now, ozone is a great thing if it's in the upper atmosphere because it blocks a lot of ultraviolet rays and it protects us. When we go to the moon, we got to be careful. There's no atmosphere, no ozone, so we're going to have to make our buildings with glass that filters out ultraviolet. Otherwise, we'll be exposed to too much ultraviolet light. Now, I've been in Los Angeles, and I don't know if you know how much you know about Los Angeles, but Los Angeles is kind of in a valley. It's like a little bowl, okay? And if they have a lot of factories and things going on, and there are no winds, the ozone and pollutant levels go up and up every day because it's just that bad air just sits in that little bowl, okay? And if they'll even have ozone alerts telling people, please stay in your house. If you're older, you have breathing problems, don't go outside because ozone's not going to be good for you. And then hopefully there'll be some winds blow in and blow that old air out and fresh it with new. And so they have ozone alerts. So what are the two forms of oxygen, the two allotropes of oxygen, O2 and O3? We have several, I'd have to look up all of them, but several allotropes of sulfur. Here's two of them. Here are two of them. Sulfur 4, sulfur 8. Phosphorus has 3 or 4 allotropes of phosphorus. Phosphorus 5, phosphorus 3. Now, the one I think they spend more time on in your book are the allotropes of carbon. Okay, so what do you call carbon that's just a bunch of atoms and they're loosely held together and they're not really tightly bound together? That's called soot, okay? You might even get some diatomic carbon. That's kind of like soot also. But if you turn the page, and I did this yesterday, another allotrope of carbon is called graphite. So what's graphite? Let me find a pencil here. Here's a pencil. So graphite is found in pencils. Oops. Let me find a pencil that has something in it. Okay. And so graphite is carbon that's bonded really strongly in this direction, but almost no bond in this direction. Get that? So it's a bunch of layers. And when you write on the pencil, they come off like little shingles. They go, come up, bloop, 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 bloop. Like that. I always thought that was fascinating. And that's why graphite is used for a lubricant. You can put it in where a key or something goes in there, and it'll just make things slide right by each other because it's graphite. What's the other form of carbon, the other allotrope of carbon that is one of the hardest materials on the planet because it's not only bonded strongly this way, it's bonded in every single direction? Diamonds. People don't understand that diamonds are made of carbon because it doesn't look black, right? Now, every once in a while, you'll get diamonds that have some impurities in it, and it's usually the transition metals. Titanium in a diamond can make it pink, and then you might have some cobalt in there. You can have blue diamonds. There's yellow diamonds. There's different kinds of diamonds that have some extra little elements in there. And then there was one more form of carbon they discovered not that long ago, and it's this guy right here. And what's this called? Yeah, Buckminster fullerene, right? Buckminster fullerene. And this is called a C60. C60, and it's a nanoparticle. It's very, very small. And it's 60 carbon atoms joined in kind of like a ball like this. Now, once they discovered it, that's one thing. But then somebody said, I wonder if we could do something with that. And some scientists have figured out some really neat things to do with this. If you would like to have some extra credit, look up articles on what did they do with buckyballs. Now, buckyball is a short way of saying Buckminster fullerene. And as a matter of fact, it was named for what? What did I tell you he was named for? Not a scientist, but an architect. And he's the one who made the geodesic domes. Remember that? So they thought that was very fitting that they would name this after the architect, Buckminster Fuller. Sorry. All right, you okay on that? So allotropes, you okay? I think I got that. Now the last part of the chapter, I want you to pay attention up here at the periodic table. And let me get my laser out because I'll be pointing out things. If you happen to have your book with you, I do allow the students to write in their book. So if you want to write in your book, it might help you a little bit here. If not, you can take notes. We know that metals like to do what with their electrons? They like to lose 1 or 2 or 3 electrons, and nonmetals like to gain 1, 2, or 3. And so I'm going to show you a little thing here. There's different ways of looking at the periodic table. If I was a college professor, I might teach it this way. This is called group 1, 2, 3, 4, all the way to 18. I could teach it 1 through 18. I don't think that's what you should do in high school. In high school, I think you should teach the A groupings versus the B groupings, okay? And if you take a look, see that little guy here, 1A, 2A, 3A, 4A, 5A, 6A, 7A, and this is 8A. It says 0, but it's 8A. Is everybody with me? Okay. Now maybe you remember something in middle school where they talked about how many electrons could be in the first energy level. Do you remember that number? 2. All right, how many in the second level? 8. Now the third can actually hold more than 8, but when you put 8 in it, it acts very special. And let me tell you something that's very ironic, and I don't mean this either. Let me tell you something that's really ironic. Some of you don't get that. Okay. But anyway, something that's very ironic is that how did we know which atoms wanted to gain or lose how many electrons? And the irony is that we found elements that didn't want to ever gain or lose electrons. The noble gases, they don't want to gain or lose electrons or share. Their electrons are in such a special arrangement, it's really stable. And that's why they don't react. You're not going to hardly ever hear about the noble gases in a chemical reaction. They don't like to react. So let me show you what happens here, though. Except for helium, every one of these noble gases has 8 electrons in the outermost energy level. Are you with me? 8 is the magic number. Now, I want you to pretend that you understand what that Roman numeral 7 means. I'm going to tell you what it means. Everybody who's in this group acts the same way because they all have 8 in the outermost energy level. All of these halogens act the same way in chemistry because they have, guess how many? 7. They have 7 in their outermost energy level. You say, what do you think they would tend to do? And elements love to be stable. What if you had 7? How far away from 8 are you? You know what they're going to do? Everybody here, they're going to try to gain 1 electron. Now, when you gain a negative electron, what happens to you? You used to be neutral, and you gained a negative electron. What happens to you? They form -1 ions. All the halogens like to form -1 ions. I'm looking at your faces. Are you with me? All right, let's go to the next one. How many electrons are in this group's outermost energy level?
6.
How far away from 8 is that?
2.
What do you think they're going to do? They're going to try to steal 2 from a metal, aren't they? And if they do, if they were neutral and they get 2 more negative electrons, what's going to happen to them? So these are -1. These are what? -2. I bet you can guess this one. -3. Can you stop for a second now? Do you understand that? Okay, now we're going to go way over here. 1A, 2A, 3A. You know that 1, 2, and 3 are they're not even halfway to 8. They're not even halfway to 8. So if you think I have 1, I'm going to try to gain 7, that's not going to happen. That's too hard in chemistry. But you know what I could do? What if you had 11 and you had 1 of the 11 is in the outer? What if you lost 1? Then you'd only have 10 electrons, and you know where you'd put them? You put them in the same place. That would be good. And so if you're less than halfway to 8, you're going to get rid of some electrons. So what do you think these are going to be forming?
Positive.
Say it again. Somebody said it.
Positive.
Positive what?
Ion.
+1. Yeah, +1. And what about these guys that have 2? They're going to lose 2 negative electrons plus 2. We're going to skip these. And now how about here?
+3.
That's it. Let's try it again. Now, look what I wrote. I wrote in the book. Look what I wrote. These tend to become what kind of ions? +1, +2, +3. What's this? -1, -2, -3. Is that hard? Okay, so let me show you what the author did with the last 3 pages of the book. And this is kind of neat. This is actually so important. The whole next chapter has to do with this. So there are only a couple questions on this test, but you have a whole nother chapter to learn how compounds form. All right, so let's take a look. Sodium comes close to chlorine. Sodium would tend to become what kind of an ion?
Positive.
Sodium would try to lose 1 electron and become a +1 ion, wouldn't it? And what would chlorine do? Look at his number. Well, he wants to do what? He wants to gain 1, doesn't he? He's going to become a -1 ion, isn't he? And you know what's going to happen? They're going to stay together. And they're going to form this compound called what? So, yes, table salt. Sodium chloride. Get that? Now, think about this. How many sodiums and how many chlorines? I'll give you a clue. every compound has a net charge of 0. I'm +1, you're -1. What's that add up to be?
0.
That's it. So table salt is 1 Na and 1 Cl. Let's try barium chloride. Ready? Barium chloride. What's barium going to do in a chemical reaction? Look, he's down here.
It's gonna lose
He's going to lose how many?
2.
2. He's going to be +2, isn't he? And what's chlorine? -1. Let's try it. So barium and chlorine, we can put them together, but guess what? That can't be a compound because that doesn't add up to 0. If I'm going to get away 2 electrons and you took one of them, what happened to the other one I gave away? Who do you think? Let's see how smart you are today.
Another chlorine.
Another chlorine? Yes. So what if you had 1 barium and 2 chlorines? Would that make a compound?
Yes.
So how would you write the formula? Ba, they never write the 1 subscript. Ba, Cl, that's it. You try one. I want to form a, you want a hard one or easy one? You want an easy one or a hard one? Easy? Let's do an easy one. Potassium and oxygen. What's the most likely compound to form between potassium and oxygen? And if you're sitting right there and said, I think I'm lost, just raise your hand. This is the first day I've done this, isn't it? Just say, can you go over that again? How would I do that? Okay. Yes, thank you. Look over here. Potassium is in this group, right? What is it going to have a tendency to do? Remember, metals like to lose electrons. How many is it going to lose? 1. So that's going to make him +1. So write down Li +1. What's oxygen going to do? These tend to become -1, but these tend to become -2. So let's write that down. So let's write down potassium's +1, oxygen's -2. That won't work because it doesn't add up to 0. So how am I going to make that work?
We have to add
2
2 potassiums.
potassiums? So what's the formula?
K2.
K2, 2 potassiums and 1 oxygen. Now, you ready for a hard one yet? Okay, let's do a hard one. What's the most likely compound to form between calcium and phosphorus? Calcium and phosphorus. If you can do this one, you can do any of them. What's the most likely compound to form between calcium and phosphorus? And my own opinion is, since I gave you this nice little packet, I'd be doing all kinds of writing on this because if I studied my packet, I'd probably do all right on that test, wouldn't I? So if I have everything right here. All right, who wants to volunteer and tell me this one? Who says, I think I got this? Who thinks they have it? All right, ready? All right, ready? I'm ready. I'm listening to everything you said. Ready? Go.
Okay, so calcium is +2.
Plus what?
+2.
2. And how do you know that?
It loses 2 electrons.
Loses 2 negative electrons. That makes it +2, right? And how do you know it's going to lose 2? Okay, because it's in the group of what? How many are in the outermost energy level? 2, and it's going to lose those 2, right? And what about phosphorus, though?
Phosphorus is -3.
In a compound, right? If it's not a compound, 0. But when it comes next to calcium, it's going to give up electrons, isn't it? I mean, it's going to gain electrons, sorry. Now, how do you know it's going to be 3?
Because it says it.
It says 5
Oh, because it needs 3
to get to 8, isn't it? All right, so it's going to gain 3 electrons, but this is not going to work. That can't be a compound because it doesn't add up to 0, so
So we need to make them both 6.
yes.
So you're going to have 3 calciums and 2 phosphorus.
Wow. And if you had 3 calciums, +2, +2, plus 2, and you had 2 phosphorus minus 3, would that add up to 0? So what's the formula?
CA3P2.
Ca3P2. What do you think? Wow. Okay, so that is that's what they do. And if you look at the last 3 pages, that's what all those little yellow balls and things are. They're ions. You get it? And if you go home tonight and just read those 2.5 pages, you'll say, I understand that. And again, I only have a couple questions on that because I know the whole next chapter has something to do with that. All right. Last but not least, here we go. I like the author of your book very much. I've never written a chemistry book. That would take years to, you look at it and you have other people look at it and they critique it and you change it, and it would take a long time. I'm just not there. I don't see myself doing that. But anyway, they have a picture here, and I do have about 4 questions on the test that have to do with this page. So let me tell you what's going on. I don't understand why the author would not use the word electrolyte on this page, because that's where it belongs. And if you have a book and the person, whoever had it before you didn't write the word electrolyte, you need to write the word electrolyte in your book. Now, what is an electrolyte? It is a solution that does what? It's a solution that conducts electricity. And you know why? Because it has ions in it. The ions will move the charge from one side to the other. So it's a solution that conducts electricity because it has ions. All right, so here we go. Are you ready? What kind of things are electrolytes? What kind of things are non-electrolytes? Let's think about it. Let's think about pure water. Pure water, distilled water. Is this a metal and a non-metal? Are they going to, remember metal and non-metal like to form ions and be ionic compounds? Remember that? Is that what I see here? No, this is a non-metal and a non-metal. It's not going to be an ionic bond. They're going to be sharing electrons in what kind of a bond? It starts with C. You had this in middle school. Covalent. Everybody got that? Now, guess what? They're not made of ions. When you put them in water is water, right? There are no ions to carry the charge. So if you were to make one of these little apparatus, this apparatus thing here, look at this apparatus. Battery, light bulb, 2 electrodes. If you touch the 2 electrodes, will the light bulb come on? Yes? Because you completed the circuit, didn't you? Yes? Now, you put them in pure water. Will the light bulb come on? No, because the charge can't travel through pure water. So you'd say pure water is a what? Non-electrolyte. Now, let's take some table salt. What's table salt made of before I put it in the water? Starts with I. Ions. Isn't it? Is it an ionic compound or not? Is it made of sodium ions and chloride ions? And then when I put them in the water, guess what? The ions separate and they get all over the place. Would salt water conduct electricity? Yes. So salt water is called a what? Electrolyte. Now, if you ever get sick and the doctor says, make sure they have a lot of electrolytes. I don't want to drink salt water. So what else could you drink? Tea. Gatorade has a huge amount of ions in it. Huge. Huge. It has Powerade, Gatorade. If you want to pay a lot of money, they call it Pedialyte. See? Get it? Electrolyte, Pedia. That means kids. Kids, electrolyte. Get it? Pedialyte. You can spend a lot of money for that, or just buy some Gatorade. And all of those conduct electricity. What about tap water? Tap water. We have some of the best water in the world. You ever go to other countries and they say, don't drink the water? We have great, I've never had anybody come here and I say, don't drink the water. I've never done that. We spend a lot of money making our water pretty good, but you know what? It would cost a lot of money to take everything out of the water. Everything. Now you can go buy distilled water. You want to do that? You want to go buy some distilled water? Okay, then you pay for it. But you know what's in here? Lots of stuff. There's lots of stuff in there. And it would definitely conduct electricity. There are a lot of ions in there. Do you know the city of Greensboro purposely puts fluoride ions in there?
Yeah.
It makes you have less cavities. Dennis is always saying, oh, do you have city water? What's that have to do with you filling my cavities? Well, he wants to know what kind of water you drink and what you cook with. If you cook with city water and you drink city water, then I knows he has fluoride treatments in it, and you shouldn't be getting a lot of cavities unless you're eating candy every day or something like that. What if you're in a rural area, well water? Somebody putting fluoride in that? No. And so you tend to get more cavities there. Yes?
What does it say under C12H22 or 11?
Oh, I'm not there yet. I'm getting there. Now, let's talk about sugar water. Thank you. Let's do sugar water. Ready? Table sugar, and you don't have to memorize this, okay? You don't have to memorize it. Table sugar has the formula. Get out of here. Okay, table sugar has the formula C12H22O11. Now, does anybody know whether or not table sugar dissolves in water? It does, doesn't it? You stirred sugar, yeah, it does. Now, the question is it an electrolyte? Is sugar water an electrolyte? You think about that.
No.
Table salt in water, that was, but what was salt made of before you put it in the water? Starts with I. Ions. And ions, right? What kind of bond do you think holds this together? What kind of bonds? Covalent. Why? Non-metal, non-metal, non-metal. See that? There are no ions there. So it dissolves in water, but you know what? If you use distilled water and sugar, it's not going to conduct electricity. It's a non-electrolyte. And the last thing I'm going to teach today, I've mentioned this before to you a little bit. Acids are chemicals that always make hydrogen ions in solution. You get that? So what do you think about acids? Would they be an electrolyte when you know that it's a solution that contains hydrogen ions and another ion? You get that? It has ions in it. Will it conduct electricity?
Yeah.
Yes. All acids conduct electricity. Vinegar, orange juice, what else do you know about acids? Pickle juice, that's vinegar. Okay, next. Bases are solutions that produce what they call hydroxide ions, OH ions. See this right here? And all bases are electrolytes also. So bases always produce hydroxide ions. Acids always produce hydrogen ions. They're both electrolytes. And there you go, a little tiny story about acids right there. All right. What do you think? All right, let's take a look at the packet. Now tomorrow, you provide the study groups. And I'll walk around the room. You get it? I'll walk around the room. If you want your group, say, come over here. We need some help. And what you would do is say, hey, there's 3 parts to this chapter. One of them was what the quiz is on, right? I didn't get the quiz grade, sorry. And that had to do a little bit of history, right? Is that correct? So that's a little bit of history, what people did. The other part, and it's pretty big. I have a lot about the world of mass, the world of charge, and I have a gigantic grid game. It's not that big. There's about 10 of them. And what do you think about the grid game? Are you pretty good at that? Okay. And then the last part, it has to do with what we looked at here, the kind of leftover things. And I think we could do pretty well. Anyway, so tomorrow, what you could do right now, unless I find another one, I might find another one. Right now, the only practice test you have is this side here and this side here. And that's what I would do tomorrow, like that. And you can also enter your notes. This is not a bad practice test. It's all right. Pretty good. All right. All right, what questions do you have for me?